Hey guys, this is Miss Pruitt, and yes, unfortunately, I couldn't be in class today. However, that does not mean that our lesson ends. So today's lesson is going to be over the laws of exponents. So let's go ahead and jump right in. Here are the laws of exponents. If I have something that has two things have the same base, but different exponents, you write it as that one common base that it has and add their exponents together. If I have an exponent, or if I have a base that has an exponent that's raised to another exponent, exponent raised to another exponent, well, you keep that base and then you multiply the exponents. If I have division and I have the exact same base on the top and the bottom, but I have different exponents, you subtract their exponents. The infamous negative exponent. That negative exponent means that exponent is on the wrong side of the fraction line. See this guy over here? He's like chilling over here above 1. It's understood that he's over 1. But look at him. He's not very happy, is he? He's being negative. He's sad. Why? Because he's on the wrong side of the fraction line. So what we're going to do is put him on the right side of the fraction line, as was done right here. He's on the right side of the fraction line. He is no longer negative. He is now positive, and he is happy. That's always true. It's even true if I had this. What if I started off with 1 divided by b to the negative m? Well, he's negative, right? Because he's on the wrong side of the fraction line. So we're going to put him on the right side of the fraction line, which would make him happy, make him positive again. And he's now in my numerator. And it's understood if something's just being divided by 1 that we don't even really have to write that, right? So that's what negative exponents do. And last but not least, anything raised to the 0 power is 1. So 5 to the 0 power is 1. 626 to the 0 power is 1. Yo mama, raised to the 0 power is still 1. Got it? All right, so let's do some examples. All right. So I'm sure we're taking our Cornell notes, right? Awesome sauce. So evaluate without using the calculator. For number 1, here's the thing. Whenever you have a negative base and it's raised to a positive exponent, a positive exponent, like 12 is a positive number, right? Well, that means that your answer is going to be positive. My answer is going to be positive. So negative 1 to the 12th power means negative 1 times negative 1 times negative 1, blah, 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 right? 12 times. So my answer is simply going to be 1. But look at number 2. What's the difference between number 1 and number 2? Number 2 does not have those fancy parentheses. So this problem means that it's going to be negative times 3 to the 4th power. So you keep that negative out in the front, and you're only going to raise the 3 by itself without the negative to the 4th power. And you guys will be getting a power chart. There should be one accompanying this video because no, you cannot use a calculator. So 3 to the 4th power, of course, is 81. Look at your power chart. And that's my answer. Sorry if that one. Yeah, let's make that a little bit thicker. All right, so let's move on to number 3. Number 3, I have a fraction raised to an exponent. So you got to share the wealth here. You're going to distribute that exponent here and there. So this will become 2 to the negative 3 divided by 3 to the negative 3. But what's up? Look at their exponents. They're negative. You never want to leave a negative exponent. You don't want to leave them all mad and angry. All right, so that means they're mad and angry because they're on the wrong side of the fraction line. This dude wants to be up here. This dude wants to be down there. So let's go ahead and oblige them. We'll move 3 cubed to the top and move 2 cubed to the bottom. I did not write their negative signs because they're positive and happy now because they're on the right side of the fraction line. Well, 3 cubed, which is 3 times 3 times 3, that's 27. And 2 times 2 times 2, which is 2 cubed, is 8. They do not have a common factor, so we leave it just like that. And I'm sure you guys have already done number 4, right? Your mama to the 0 power is, so 5 to the 0 power, of course, is 1. All right, let's move on. All right. Look at number 5. And it's weird, I know. It kind of looks like number 5 is, go back. Kind of looks like number 5 is a part of the problem, and it's not. So let me go ahead and separate it like that. This is 5 times 5 squared. So what we really have here is 5 to the 1 power. It is not there. It's invisible, but it's understood to be there. So just like in one of our properties, when you have the same base but different exponents, you add those exponents together. So this is the same thing as 5 to the 1 plus 2. The answer is 5 cubed. Look on your power chart. The answer is 125. Boom. Not bad, right? Look at number 6, though. Number 6 looks a little complicated, but we can work this out. I have a whole bunch of numbers that don't have the same base, so we need to make them have the same base. Looking at your power chart, I'm looking at it, I see that I can rewrite 8, 64, and 16 all with them all having the same base of 2. So let's rewrite these guys with bases of 2, starting with 8. 8 can be rewritten as 2 cubed. So that replaces the 8. However, it's 8 cubed. So the cubed has to stay out here. And matter of fact, I think I'm going to run out of room. Let's see if I can squeeze it in. Times, well, I see that I can rewrite 64 as 2 to the 6th power. But the 64 is raised to the negative 1, so this dude has to be raised to the negative 1 power. Hopefully you guys can see that. Okay. Divided by, again, looking at my power chart, I can rewrite 16 as 2 to the 4th power. Sorry about that. Raised to the 2nd power, because that's what's already there. All right, so now I feel a little bit more comfortable with this. So now let's keep going using my properties. Remember, what are you supposed to do if you have a power raised to a power? Because I have 2 cubed. You're supposed to multiply the exponent. So this becomes 2 to the 9th power. Times, well, I have 2 to the 6th power raised to the negative 1 power. You multiply the exponent, so that becomes to the negative 6th power. Divided by 2 to the 4th squared. Again, it's a power raised to another power. So you multiply them together, and this becomes 2 to the 8th power. So let's continue using our properties then. These two numbers in my numerator have the same base, but different exponents. So what are you supposed to do? You're supposed to add those together. So 9 plus negative 6 will be 2 cubed. Divided by 2 to the 8th power. Well, what is the property? When you have the same base but different exponents with a fraction, you subtract. Well, if I subtract these, I would get 2 to the negative 5th power. A negative, he's upset because he's on the wrong side of the fraction line. So I'll rewrite him as 1 to the 2/5. And going ahead and looking at my power chart, I can see that this becomes 1 over 32. And that's my final answer for that one. Whew. All right, that wasn't so bad. So maybe we can finish these up even more quickly. Let's see, number 7. 3a times 4a cubed. Well, multiply what you can multiply. You multiply coefficients together. So, I'm doing something a little different, so it's coming out a little differently. Sorry, guys. So, 3 times 4, and 3 times 4, of course, is 12. Then, what I really have is a to the first power. Let me write it over here. If we rearrange things, we'll have 3 times 4 times a to the first power, which is understood, right? Times a cubed. Well, 3 times 4, of course, is 12. A to the first times a cubed. You can ask yourself, well, how many a's do I have? 4. Or, again, using your properties, you can see that those a's are the same. The bases are the same. You just add the exponents together. So the answer is simply 12 times a to the 4th power. Look at number 8. It looks a little crazy, but we know the properties, right? So it's not that bad. You do what you can do with the numbers, like the 27 divided by 45. You work with that first. Well, 27 divided by 45, they do not reduce to a whole number, but they do have a common multiple, or common factor. Excuse me. So they both can be divided by 9, right? So 27 divided by 9 is 3. Let me draw my fraction line. 27 divided by... No, let's do this in a different way. 27 divided by 9 is 3. 45 divided by 9 is 5, right? All right, so then let's go through A, B, and C to see what side they will end up on of our fraction line at the end. So I have a cubed over a to the 4th. Remember, that means you need to do a to the 3 minus 4. 3 minus 4 is negative 1. So I'll be left with a to the negative 1 power. Now what about b? I have b cubed minus absolutely nothing, so he stays. And what about c? I have c to the 5th divided by c squared. That means we're going to do c to the 5 minus 2. 5 minus 2 is 3. Well, I see 2 positive guys. They're going to stay up at the top. However, I see a to the negative 1 power. That means she needs to go down to the bottom of the fraction line. So 3 stays at the top. 5 is at the bottom because we already had the fraction 3/5. And that a to the first power, that a to the negative first power, is going to join this 5 all the way down here. She's negative up there with that 3. She wants to be positive, so she has to go down to bottom. And leave b cubed and c cubed at the top. That's our final answer. Not bad. 2 more. Number 9. Well, I have this exponent on the outside. That means that that exponent needs to be distributed to the coefficient, the x, and the y. Everybody gets a piece. So I have negative 3 cubed, x cubed, and y squared cubed. All right? So I have a negative number raised to an odd power. If you ever have a negative number raised to an odd power, your final answer is going to be negative. And 3 cubed, look at your power chart. You will see 3 times 3 times 3 is 27. It's got 27. X cubed, there's nothing to do to it, so just bring it down. And I have y squared cubed. By the way, that's the same thing as y squared times y squared times y squared. Well, how many y's do you have? 6, right? Or you can always remember that I have a power raised to another power. You always multiply. So it's y to the 6th power. And that's the final answer. So last problem. I'm going to go ahead and actually erase this so we don't get confused. Last problem. I have a to the x plus 3 times a to the x minus 3. Remember, you have the same base. You simply add the exponents. So we're just adding the 2 exponents together. Well, positive 3 and negative 3 cancel out. And 1x plus 1x is simply 2x. So it's a to the 2x power, and that's the answer.